right, so welcome back. Now that homework 0.0 is over with, we're going to get into our semester-long project, and in the next 2 weeks is phase one, right? And as part of that entire process, what you'll be doing is you'll be maintaining a design document, an IEEE's 1036, I think it is, the standard design document that you'll be refining as we go along. To help you with that, I've asked J.C. Andrews from the, she's an associate director in the Writing Center, and I've asked her to come and help talk about technical writing, in particular writing to design and communicate in computer science or computing in general. All right, so let me expand that. There we go. All right, yeah.
Hey everyone, I'm JC. I am an associate director in the Writing Center, and I'm also a second-year creative writing PhD student. And I'm here to talk a little bit with you all about some technical writing skills and techniques that should be useful to you throughout the rest of your time at UNL and then beyond. So the first thing we're going to look at are some of the skills that are considered essential in your field, particularly critical thinking and problem solving, professionalism and work ethic, and oral and written communications. So as you can see, about 95% to 100% of respondents consider these skills essential, and only about 40 to 55% are proficient in these skills. So practicing and developing these skills will help you stand out in the job market.
And these are employers, by the way. These are employers that are saying these are the essential skills that we look for in people that we're looking to hire, but only about 40% of applicants or actual new hires are proficient in them. And when you put it into context, I meant to incorporate an article I found a while ago. Something like 60 or 70% of the United States people are like all across the board are functionally illiterate, meaning that they're at a 6th grade reading level or below. So if you can, you're already head and shoulders above like the general populace. But if you can get yourself a head and shoulders above your peers when you're going into the job market and have these skills, these proficient skills, it's going to be a lot easier to distinguish yourself from the 100 or so applicants that are trying for the same job. And this is exactly the kind of data that we get from our IAP, which is our industry advisory panel, year after year of we need these folks with these essential skills. So even if it's as simple as drafting a coherent email, right, then you're going to be able to distinguish yourself from a lot of other applicants.
So hopefully the 3 techniques that we're going to practice today will help you do that. So we'll work on free writing and looking at the parallels between coding and writing, reverse outlines and how they can help you learn to code, and then analyzing your design documents and how they communicate your code. So let's start off with our free write, looking at the parallels between coding and writing. So in writing good code is like writing a novel. The author posits that the process of writing code and the process of writing a novel are similar. In one section, the author focuses on drafts. So I want you to think about how you draft an essay or any piece of writing and answer these questions. What are the steps you take to get from an idea to a final draft? And how are these steps similar to your coding process? And the only rules here in the free write are that you keep your pen or your hands moving as you're typing. Don't worry about grammar, punctuation, spelling, any of that. Just try to keep writing the whole time. And we'll take about 4 minutes for this, and then we'll come back and discuss. Take about 2 more minutes. All right, go ahead and start wrapping that up. Can someone walk us through your response to that first question? So what are the steps you take to get from an idea to a final draft?
Yeah.
Usually I'll like create a show of all the ideas I have, and then I'll like check to see if like those ideas make sense. And then once I have those, I'll sit down and like just start writing down and start to create. What's gonna happen.
So you brainstorm the main points, you'd also organize them, right? Into some sort of outline, right? Okay,
Nice.
yeah.
I like write it out, and then I'll go through it again and fix any like grammar things. And then while I'm doing that, I'm also like getting rid of any points that I think are dumb.
It's a proofing and editing process. Right. Others? One more? Okay.
Okay, what about that second question? So how are these steps similar to your coding process?
Yeah.
In programming, it's often wise to have, an idea of where you want to go with your code and what you need to accomplish it.
Okay. So you'd also outline code, right? Step 1, open the file. Step 2, ... right? Yeah.
Pretty, for myself, even work, all my studies, everything is in a way similar. So you would always have a template of some sort. Introduction, summary, body, conclusion, etc. Even with the programming process, you'd have the documentation. You'd have the beginning, the description. You then have the body, then you have the end.
So everything has the same basic
Yep,
structure.
about the same basic. So everything I have a template for in some sort of fashion.
Yeah.
That I create, and you just start from there and then start filling it in, deleting, adding, removing as needed.
Okay.
And that really just saves a lot of time rather than thinking of, which form of document that I need. It's all pretty similar.
Okay. Right.
Everything.
You also had a hand up? Go ahead.
Yeah, like Sarah was saying, sometimes I find it best just to start working, start writing, and once it actually gets to work, once it starts working, then I go back and edit it, and maybe get rid of a variable I don't need,
Right.
or I can comment things out to make it more efficient. Sometimes I need to work first,
So
and then I can go clean.
what's that called in computing? So you've got a finished project, a product that actually works, but then you go and you change stuff to make it more efficient, but the function stays the same. You clean it up, you make it a little bit better. That's called refactoring, right? You already have something that works and that is good enough, but then you go back and you make it a little bit better, right? Editing, basically.
So free writing is a great tool to get started. If you feel like you have writer's block, you can just start free writing and you'll be surprised at the ideas that you come to. It just helps you get over that hump, right?
Yeah. And that's also one of the most common things with coding, especially from students. I don't know how to get started. Just get started by free writing, right? Just start writing hello world lines if that's what it takes to actually get you started. And then brainstorm, write down 5 ideas. 4 of them might be terrible, but it's the 5th idea that is good and that you start to go with. So that's the technique, right? We did this in the context of your design document, but this is a technique that you can use anytime you've got some sort of a writer's block. If it's writing a 5-paragraph essay, a poem, or your design document that's due this Friday.
Okay. Next, we're gonna look at reverse outlines. So how do you make a reverse outline? You'll start with a complete draft or an almost complete draft usually. You'll summarize the function of each paragraph in 1 sentence or less, and then number your paragraphs. So let's try this. Who can tell me the function of this first paragraph here in blue? In 1 sentence or less.
So an introduction.
Yeah, exactly. So introducing yourself and your purpose to the reader. What about that second paragraph? Yeah.
Your experience.
Right, your qualifications. Explaining why you're qualified for the job. So this is how reverse outlining works. A thing to keep in mind, if you can't summarize your section or paragraph in a sentence or less, you might not be communicating as effectively or efficiently as you could. And I will pass it over to you.
So we'll do the same thing, but with code. So here's the problem. It's an exercise that I've given before. It's computing what's called a suffix array. So you start with a string, and then you start taking the suffixes, the things that end with it. So the string itself is a suffix of itself. Then you take off the first letter, right? And that's the next suffix. You take off the second letter. That's the next suffix. And then once you've got all the suffixes, you sort them. And this has applications in DNA processing, natural language processing, and a couple of other things. Here's a piece of code that solves this problem, right? Take maybe 30 seconds to look at this code, and then I'm going to start asking you to reverse outline it. All right, to start, how many bullet points would you have? 3? Okay, why did you immediately, who said 3? Why did you immediately jump to 3?
Because they're grouped together.
Yeah, we call that chunking, right? You have paragraphs, just like you have paragraphs in writing, you have paragraphs in code that are separated by vertical white space. There's 1, 2, 3 chunks in there, right? That's how you organize code, right? So what's the first one? I mean, it's the first chunk, but summarize that like we did with the paragraphs that we had. Anyone? Yeah.
Make the list.
You're making a list. You're initially creating the suffixes, and that's actually 2 parts, right? You are creating the new array, and then you're running through for each substring and adding it to the array list. All right. What's the second one? Yeah.
Sort the list.
You're just sorting it, right? Plain language right there. Right? What's the third one?
Printing it out.
You just printed it out, right? So that was easy, right? That was really straightforward. here is another chunk of code that solves the exact same problem. It is correct. Right? I'll give you another 30 seconds here to reverse outline that. So you're not supposed to, right? Would it take you? How long would it take you to actually do it? Would it take you 1 minute or 30 seconds like you did the last one? No. Okay. Why? In other words, you are unable to reverse outline this, right? And if you're unable to reverse outline something, that tells you that it's bad. It's a bad draft and needs to be updated and fixed. But more specifically about this code, what are some bad aspects here? If you were to grade this, or if you were to write this and receive a grade for it, what would you call out as bad practice? Yeah.
Leaving the commented things at the top.
Yep. The commented cruft, right? Dead code. Don't leave dead code. It's a distractor. Yeah.
A lot of nested for loops.
Lots of nested for loops when one for loop will probably do it, right? Yeah.
Like lack of function, circular chunking.
Yeah. I mean, there is kind of chunking, but I would agree that there's huge amounts here. What is this doing here, by the way? This chunk right here. It's sorting, right? It's using selection sort or something, right? And instead, in the original, what did we do? Collections.sort, right? So there's a lot of repeated unnecessary code, right? What about the variable names? Start at the top. IJK. Should they be declared there? No, they should be scoped to the loops that use them. Also, K, is it actually ever used? Nope. How about temp2, temp array, right? We have 3 variables, and I think we only don't ever actually use any of them, or maybe we do, right? I guess we use temp array to split, right? And then down at the bottom, what are we doing? We're making one big giant string and then printing it all out, right? Instead of that simple for loop that printed out each line. Right? Okay, so again, you are not supposed to reverse outline this, because if you can't, then that's a pretty good indication that this is bad writing, that we need to go back and we need to edit and proof it. Right? All right.
So thinking about your design documents and writing to communicate, I want you to take maybe 2 minutes to respond to these questions with that document in mind. So what are you writing? Who is it for? Like, who's your audience? And why is it important? So why is it important to you, and why should it be important to your audience? And we'll take 2 minutes just to write that. Take about 1 more minute. Okay, can go ahead and start wrapping that up. Who can answer that first question for us? What are you writing? Yeah,
Like a plan.
plan?
Plan, okay.
Can you say more about that?
Like it's telling you like the steps you want to take to reach your end goal.
Okay,
This is what I want to do in this work.
all right. So we'll come back to that here in a second.
Who is it for? Who's your audience for this document?
All right, we'll come back to that one then. Why is it important? Yeah, go ahead.
It's for like yourself and the grader.
Okay, so there is an aspect of grading here, right? But with this design document, we're trying to get you to have exposure and some skills in technical writing. So when you write it, you shouldn't be writing it to us, right? It needs to be treated as a real project, as a real design document. So it needs to be professional. It needs to be towards the people that it's intended for, which is a technically competent audience. You're not writing things like, oh, Java is a programming language that we're using, and every line ends with a semicolon and dot, right? No, a technically competent audience will know that. So you're not writing it for the client. You are writing it for the course, but you should write it as if it were a real project. And you're writing it for what you can assume to be a technically competent audience. In other words, those low-level details of, I used an enhanced for loop for this part, that doesn't belong in this document, all right? It should be high-level abstract. And why is it important? Yeah.
So you're organized while you're writing your code.
Right, so it has a couple of purposes for this course, right? Your first phase is due on the 13th, right? We are organizing these things into called sprints. We'll talk about that at the end of the course. But the first week here that you're going to be drafting this design document because you're putting in an investment, right? You're thinking about the design before you actually go to the implementation. Now, the implementation, when you actually do that, you might find, oh, there was a design flaw. We've got to go back and change our design a little bit. That's fine. But at least you have something to work with, that you're not just starting from scratch, or you're also getting feedback from us that, no, that's not going to be a good design for reasons X, Y, and Z. So go back to the drawing board and think about it. In other words, it forces you to think about your design 1 week ahead of time, or at least 1 week ahead of time, right? And it's an investment. It's the opposite of that technical debt that we've talked about before, where you either have to do it right the first time, or you're going to have to find time to do it over, right? And this is the opposite, because you are investing your time. You're investing your time into a design up front that you've whiteboarded, that you've actually written down, and you've thought about, right? And that investment then will pay you later on when you don't have to work so hard in your actual implementation. Right? So if you open up the design document at some point, which you should be doing for today and tomorrow, you'll see this up here. The design document should be clear and comprehensive enough that a reasonably technically competent person could reproduce your system design, though not necessarily every detail, with identical functionality without access to your actual code base. Et cetera, et cetera. And we've got a rubric for this, right? It's actually not a process-oriented document. There are process documents, but that's a completely different standard. Even before that, there would be like a requirements document where you're going to the client and you're saying, we need to build this system. What are your requirements? You gather those, you give that back to the client, they approve it. That's for the client, right? Then you go through a process document of, here's my plan. You create a Gantt chart like we did for you. But this part is the design document, where you are talking about the design. You're going to be writing it as if it is already done, right? Because it's a draft. By the end of the semester, it will be done, and it'll be a set design document, right? So it's not a process document, more so as, this is my actual design. If you go back and you change your design, that's fine. You go back and change your design document. Right? Here's an actual example from the wild. This is from Deloitte, which is a large software engineering firm, consulting firm. Make a lot of money from consulting, especially the government or governments, right? And this is an actual design document that I found of theirs online somewhere. We don't need to look at the content so much as how information is presented, right? So what do you see immediately here? Bullet points, right? So do you see a big giant wall of text that indicates I'm reading a novel, right? Right? No, you see things split out and as little text as possible. That's technical writing, right? That you want everything to be consistent and when you've got 5 points to make, it should be a bullet point. It shouldn't be a big giant paragraph where I have to pick through what were the 5 main points of this paragraph. Right? What about each one of those bullet points? What do you see? Oh, say what? Oh, sure. What about the bullet points themselves? Requirements phase during the requirements phase. System design phase during the system design phase. Right? Dot, dot, dot. Right? Boring, right? Consistency, though, right? That's what technical writing should be. You're not writing a poem. You're not writing something to engage a reader and sell millions of copies of your novel. You are writing to convey information. The quickest, best way that you can convey that information is the best, right? So make it boring. Don't write out too much, right? In fact, here is the database design section for that design document. What do you see? How much text do you see? I think it's one sentence that says, look at the figure, right? So you've heard of the expression, a picture is worth 1,000 words? Literally. If I were to write down the design of this database, it would take me pages and pages and pages. Whereas if I just create what's called an entity relation diagram, ER diagram here, right? Any technically competent person could see that and go, yeah, I could redo that, right? I could implement that really easily. Right? Now, if you were to give this to the general public, or if you were to give this to a technically non-competent, I don't want to say incompetent, but a technically non-competent client, right? They're not going to look at that and say, yeah, that looks good, right? Or what the hell is this, right? But a technically competent person can look and see, oh, I see what the primary keys are. I see what the naming convention is. I know exactly how many tables and exactly how many columns there are and what each column does, right? So you will, when you go to your database design, by the way, this is exactly what we want to see in your design document. You will auto-generate this, right? Actually, in your sketch, you'll sketch it out on a piece of paper and take a picture of it. When you've implemented it, then you'll replace it with an actual ER diagram. Right? All right?
Yeah. So we hope that the techniques that we showed you today are helpful to you, but also we'd love it if you came into the Writing Center. So we have online appointments, we have email appointments, or you can come in person. We're located in Andrews 102, so just on the first floor, and there's a big sign on the outside, so you can't really miss it. We offer one-on-one sessions with undergrads and grad students for writing in any discipline or any stage of the writing process, whether you're brainstorming, organizing your ideas, polishing a final draft, or anything in between. You can also bring in non-academic writing, so CVs, resumes, job applications. I helped someone with a job application this past week. Literally anything. Even if you don't have something and you just want to brainstorm ideas, we can do that with you. Okay, so the 3 types of appointments, we have video chat appointments, we have email feedback or e-tutoring appointments. So how those work, say you have an appointment like 6:30 to 7 p.m. You upload your document the day of. Someone will work on your document from 6:30 to 7, and then it will be uploaded back to you by 7 p.m. And then also we have the in-person appointments. This is actually wrong on here, but we have 25-minute or 50-minute appointments. It's up to you. And then what to expect and prepare for when you have an appointment. Like I said, you can bring anything in, but just bring whatever you have in related to the assignment or project that you're working on. And if you don't have anything, that's okay too. Any questions about any of that? No? Okay, come see us. I have bookmarks too with all of this information on it, and I'll pass those around maybe. I think I have enough.
And I would highly encourage you to prepare your resume and your cover letter, a generic cover letter right now, because in a week or two, maybe it's 2 weeks, I forget, is the spring career fair. Now, even though most of you are freshmen and may not be looking for a job, may not be looking for an internship, you should, right? Even if you're not looking, then going there and getting practice of meeting an employer, shaking hands, those soft skills of being able to talk to a stranger in a professional tone, right? You'll be able to do that in a low stakes environment if you go to the job fair. When you go to the job fair, you're going to have copies of your resume and copies of your cover letter, and you'll be handing them out. Eventually, they'll be calling you, right, to get a job. And I highly encourage you to do this even as freshmen. I'm a faculty advisor for software engineers, and as part of their degree program, they're required to have at least one internship. They take it for credit. And by the way, you can take it for credit too. Up to 3 or 6 credit hours can be internship credit hours, depending on your major, computer science or computer engineering. Anyway, I've gotten a lot of students lately. I don't have an internship. Well, when did you start trying? Right? Well, this last semester, right? No, you should have been trying when you were freshmen, right? Because the job market seems to be getting a little bit tighter right now. But again, if you have these skills, you're going to be you're going to bubble up to the top of the list. If you've gone out and you've met 50 employers at career fairs, right? Then maybe one of them will be calling you rather than you having to apply, right? So I would encourage you to write those two things, or, cover letter and resume, and take it to the Writing Center before the career fair in a couple of weeks there. I'll also point out, going back to this actual course here, where are we? Yeah, there we go. What you should be doing for today and tomorrow is you should be reading the project overview. It's going to look daunting at first. It's a sales system for Cinco computing consultants, right? They sell equipment, services, licenses. They also lease equipment. Here's their business model, et cetera, et cetera. How much taxes are, how things are charged, basically. It's going to look like a big project. It actually doesn't look like a big project, but don't worry, because you'll be going through 7 different phases, right, that we've already outlined for you. You only have to worry about phase 1 over the next 2 weeks, right? Phase 1 is data representation. So you'll be designing your initial objects. You'll be reading them in from CSV files. You will be persisting them out to JSON and XML files. You'll be using libraries to do it, right? So don't think I have to write a whole bunch of code. No, you'll be leveraging libraries that we suggest to you, right? So that's the project overview. What you should also then look at is the template. So this is a LaTeX version. If you want to use LaTeX, great, go for it. But there's also a Word version. It just doesn't look as nice, right? What we're expecting for this Friday is that you have gone through the project outline, you've gone through the first assignments handout, and then you've gone through and you've drafted your first very, very rough draft of this design document. Don't leave the project title there. That's a placeholder, right? Replace that. Don't leave Joe's student there. Replace that. Those are the small things that you can do. Each section, right, there's the full table of contents there, but each section has a placeholder telling you exactly what we're looking for, what to do and what not to do, right? Keep your writing professional and a technical style. Keep things short, but provide sufficient details that another development team would be able to reproduce your system. Do not use personal pronouns. Write in present tense, as if the project is already done, right? The document is about the design of the system, not the process. Don't refer to, we did this, then we did this, right, et cetera, et cetera. Do not write this as a class project. Write it as if it were a real project, right? Those are the things that we're looking for. Specifically for the first draft, if you look at CampusWire, we tell you exactly what we'll be looking for. I mean, you could write it all if you really wanted to. Get the entire semester done in this weekend. Don't do that, right? The first draft we're going to consider, you need to have the introduction. That's where you're telling us who the client is, what their business model is, basically proving that you've read the handout, right? You should have a start on section 2, the overall design. You're going to come back to that, and as you add features to this system, you're going to come back and add those features to this section, right? What features are in there in the first phase? You're going to have a sketch outline of section 3.2. What data classes are we implementing in phase 1, right? If you tell me, oh, we have this one class to do everything. Nope, we know that that's a bad design immediately, right? that there should they sell 3 things. We're expecting at least 3 classes there, right? And what other classes are you putting? Because are you putting everything into one big giant class? No, right? How are you organizing all the functionality of this? That's what we're expecting in the first design phase. If you want to make a diagram, like that diagram, right? I'll show you how to make it what's called a UML diagram later on. It'll be auto-generated by your IDE. But if you just want to say, well, here's my class, here's my class, here's my class, and here's my class, and this is what, and then my text says what each one does, great. Don't bother drawing out a complex professional diagram like this. Go ahead and draw it on a whiteboard. Take a picture and put that in your document as a placeholder, right? That's the kind of thing that we're looking for in your first draft, okay? Any questions on technical writing, the Writing Center, or your first design document draft? One other thing I'll mention here is that as the honors course, you're required to do the bonus. So make sure that you're reading the first assignment, because the bonus is handing in a test case 1 week ahead of time, right? Auto-generate it with Makaru or something else, right? That's the one instance, by the way, where you are allowed to use AI to do your work for you, right? Where AI, ChatGPT, generate 10 random people using Star Wars or Star Trek or Harry Potter or whatever theme, right? Give me 10, and it'll generate that data for you, right? So otherwise, you can use something better like Makaru. Makaru.com will generate mock data for you. Right? There's a question over here.
Yeah, no question. It's
No?
really,
Okay.
really a statement. So,
Okay, sure.
I work full-time.
Uh,
And I just want to let kind of everyone know, I work for the federal government. And I've also worked with state and contractors, small businesses, veteran-owned, large companies like Esri, doing project management. And I'll say leadership and, even the directors, even the governor, bullet points, they love them, they eat them up. Project managers, Gantt charts, that's like their living lifeblood.
so Gantt charts in the wild, are in the wild. There you go.
And, if anything's not, referenced there, so it's a big thing, and I would say, as developers, I haven't met a similar developer. We're all our different special people, but they somehow get it done. So keep in mind that no matter what we're doing, that it's quite similar.
Yeah.
You still have to follow those items, and when you produce those results, I myself I do some coding, but I mainly work with contracts and a lot of data and Excel sheets and other things. So, and I will say the job market's not it's changing. It's more volatile than anything.
Yeah.
And it's becoming a lot more technical. So it's changing a lot from just degrees to now degrees and experience. So the earlier you get in with somebody for an internship, really leaning on those skills and relationships.
Yeah.
It's really not what you know, it's who you know.
And with internships, I would add, that's your opportunity to learn about companies and what companies you want to work for and what companies you don't want to work for, right? Because you get to see what the company culture is like. Right? To just add one more thing onto that, we try to make this as close to real development as possible. Like I alluded to before, sprints. In the real world, sprints are about 4 weeks long, right? And you have a very prescribed process before we start our sprint, we decide what we're going to do for that sprint. And it kind of protects you from management coming in and saying, drop everything, this is what needs to be done. Because you commit to what you're going to do in that sprint, and then you only do that, right? This is self-management, basically. that developers should know how to manage development better than an MBA would, right? And then at the end of that, you have a retrospective. What went well? What didn't go so well? What can we do better for the next time? And in addition to Gantt charts, you have what are called burn down charts. You'll do this in maybe a software engineering course, where at the beginning you've got all this work that you've committed to. At the end, you should be at 0. The ideal burn down chart looks like a nice linear burn down chart, because that means that you are working at a steady pace. A bad burn down chart looks like this. Procrastinate, not get anything done, procrastinate. And then finally on your last day, you cram and you try to get everything done. Or you didn't get anything done, right? That's even worse, right? But then you try to get everything done. That means that you're working at the deadline, right? Another bad burn down chart would be where you start here and then you immediately got done, right? Well, you undercommitted, basically, right? You said, yeah, I'll write that Hello World program for the next 4 weeks, right? And then you get it done, and okay, now it's vacation time. Managers wouldn't let you do that, right? Or product managers wouldn't let you do that. But again, we try to keep this as real world as possible, even without enforcing. Like I didn't talk about sprints at the front of at the front, or requirement solicitation, or all of these things. It's kind of built in as an undertone to this course. Yeah. Any questions? No, thank you for that. Having an industry perspective, well, I should say a fresher industry perspective than mine, is always good. Right. Make sure that you've got your CV or your resumes and your cover letters, and start going to those. And by the way, start going to all the ones that we invite people to down in the Avery. Like Garmin has come, I think. Who's there just recently? I forget who was there, but we almost on a weekly basis we have employers coming and setting up booths somewhere in Avery, right? So and don't just limit yourself to industry. Like for example, Bits and Bytes, we posted that there's a new faculty member here, Dr. Kim, that is looking for 3 Unity developers to do research, right? That would also count as an internship if you wanted to take it for credit, right? But he's looking to hire 3 undergraduates right now, right? So I'll keep your options open. All right. All right, then we'll continue on Wednesday. Back to Java.